vertical and horizontal particle motion. And I guess I should maybe big picture this for just a moment. We're going to do this Tuesday and Thursday and Friday. Tuesday is no calculator. Thursday and Friday are with calculator. And the test will have a part calculator, part no calculator. That was your question. And when we get closer, I'll give you more information about what's on each part of the test and which day and all that stuff. Okay, but big picture, vertical and horizontal particle motion. In general, t is time. In theory, t could represent something else, although it's usually time for us. Question, if t represents time, can t be negative? It's like, well, yes. You just have to be careful, because if t represents noon, then what would 10 a.m. be? What's t at 10 a.m.? Negative 2. Presuming we're talking about the immediately preceding 10 a.m., not 22 hours away, 10 a.m. So, yes, kind of depends on the question, so be careful. Don't just throw it out because it's negative. Like, think about what's going on, and you might be able to go backwards in time. S is frequently used for the position. But other variables could be used. Sometimes x for horizontal, since x is a left and right thing. Y is often for vertical, because y is up and down. But a lot of times we just do s. Velocity is the derivative of position. Another way to write that is ds dt, or just s prime, either one. And then acceleration is the derivative of velocity, which makes it the second derivative of position. Those are two super important things for this unit. Velocity is the change in position. Acceleration is the change in velocity. Speed is the absolute value of velocity. Do you remember from physics the difference between speed and velocity? What was you could use the fancy word, or you could just tell me in words. Velocity has direction. That means velocity is a vector, speed is a scalar. We don't really use those words, but that idea that velocity has direction, a negative sign implies direction, and so speed will never be negative because it doesn't have a direction. It's just like, how fast are you going? So speed is absolute value. That will be super important in a moment. Here's some more things like that you talked about in physics. The particle is at rest when the velocity is 0. So you remember reading those physics problems and looking for kind of the keywords that told you things without telling you things. Particle moves to the right or up when velocity is positive. The particle moves left or down when the velocity is negative. Okay, I think that makes sense. The displacement, here we go with more physics crossover stuff. The displacement of the particle on the time interval is your ending position minus the starting position. Ending position minus starting position. We don't do integrals yet, but that's how we do. Again, this doesn't help yet because we don't know what integrals are. Displacement is just where you started minus where you finished, as opposed to total distance. Displacement versus total distance is the sum of the total distances to the right and the sum of the total distances to the left. So, I mean, total distance means what it says it means. Like, how far did you walk? Not where did you land compared to where you started. So I think total distance, people don't get confused because they understand what total distance means. They got a feel for that. Displacement is where people get confused. Distance is always positive, so use absolute values. When we get to integrals, this will be important when we get to integrals. Displacement doesn't have absolute value, total distance does. A better way to think about this is, let's see, there's not room to write it here. 4 times around the track. Probably did this exact example in physics. If you walk 4 times around the track, let's talk about displacement versus total, whoops, that should say total distance. Overhead view here. So here's our start. Walk around once, twice, 3 times, 4 times. So we start and finish at the same spot. What's our displacement? 0. Where we landed minus where we started, we didn't go anywhere. But what's the total distance traveled? What's that? 4 tracks. Let's see. Let's assume it's a 400-meter track, and we'll just say 1,600 meters. I guess that depends on like if you're running the inside lane or the outside lane, whatever. The big thing is displacement 0 because you started, or you landed where you started. You didn't go anywhere. To find when the speed is increasing or decreasing, you know what? That's a lot of words. Let's skip down to this. This stuff is more important down here. The particle is speeding up when velocity and acceleration have the same sign. Okay, that's easiest to think of if you're speeding up in your car. Right? You're going 15 miles an hour, you press the accelerator, you speed up. Speeding up backwards is a little bit harder. If you're going backwards and you press the accelerator, you speed up in the negative direction. So your velocity is negative, your acceleration is negative, you're still speeding up. This is what throws people off. Slowing down is when they're fighting each other, when velocity and acceleration have different signs. So you're rolling forward at 30 miles an hour, you start to push the brake. Your velocity is still forward, but your acceleration is negative, you're slowing down. This comes up frequently, and it's one of the things that people forget. Speeding up, velocity and acceleration have the same sign. Slowing down, velocity and acceleration have different signs. So again, I think it makes sense. If velocity and acceleration are fighting each other, then you're slowing down. If they're pointing in the same direction, then you're speeding up. You're speeding up forward or speeding up backwards. All right, let's work a problem with all this stuff. Look at this. Problem 1 is the whole page long. The position of a particle that is moving in a horizontal line is given by this equation. T is in seconds, T is greater than 0, S is in meters. Okay, find the velocity of the particle at time t. Well, we said velocity is the derivative of the position. So ds dt, 3t squared minus 12t plus 9. Little side note for multiple or for free response questions, you must show that step, that v is s prime or ds dt, to show where it comes from. You can't just jump straight to v equals, because then I don't know where you got that. I mean, I do, but you have to communicate where it came from. All right, what is the velocity at exactly 2 seconds? All right, well, what did I do to find the velocity at 2 seconds? Plug in 2. Again, communicate what you're doing. Don't just write down an answer. So I'm taking V, I'm plugging in 2. Let's see, 12 minus 24 is negative 12, plus 9 is negative 3. Oh, but I can safe stop that. Why am I messing with this? Just don't mess this up. Right? Safe stop, especially without a calculator. Velocity at 4 seconds would be same process, plug in 4. 3 times 4 squared minus 12 times 4 plus 9. Again, you could figure that out, not too difficult, but why risk it? Safe stop that, leave it alone. Find the acceleration at time t and at 4 seconds. Well, we said the acceleration is dv dt. So let's take the derivative of v. 6t minus 12. And again, you have to show this. That's communicating what you're doing. And then a of 4. 6 times 4 minus 12. Oh, indicate units of measure. Do you remember the units for acceleration? Meters per second squared. When is the particle at rest? At rest. What's that rest mean? What's 0? Velocity is 0. Justify your answer. That just means, how do you know? Well, rest means v equals 0. So 0 equals 3t squared minus 12t plus 9. Okay, is that a safe stop? Definitely not. When means find time. Find t. I don't have t equals. I mean, I'm close, but I don't have t equals yet. So let's see. I could factor out a 3. Would make life easier. And on a no calculator problem, you're probably going to get factorable and simple answers. So we're not testing your computations and your calculations. We're just testing your calculus knowledge here. So t equals 3 and t equals 1. Particles at rest. Because rest when t is 0. When is the particle moving to the right? When is it moving to the left? Justify your answer. Okay, how would I know that the particle is moving to the right? So don't answer the question yet, just like this specific question. What would tell me that the particle is moving to the right? You could get there from distance, but a better way to say it, when v is positive. If v is positive, we're moving to the right. And then moving to the left, v is negative. So how am I going to figure that out? Well, I figured out where velocity is 0. So let's do that sign chart thing. So I know where it's 0. Let's plug in. So I want to find v of 0 and v of 2 and v of 4. Okay, I could plug those in. I've got several expressions for v. I've got a factored expression, but also have this expression all the way at the beginning. V of 0, that's going to be easy. That's just going to be 9. So that means v is positive. V of 2, a lot of times AP test does this. This is a good thing. Why is this a good thing? We already found V of 2. They asked us for V of 2, and we answered it. We didn't think anything of it. And here we are a few minutes later, and we need V of 2. I guess the problem is I need to know if it's positive or negative, and I don't really know that yet. I need to go back and answer this question a little bit more accurately. 3 times 4 is 12, minus 24, plus 9. Negative 12 plus 9 is negative 3. So V is negative. Oh, I need to be careful here. Moves to the right when V is positive. Moves to the left when V is negative. I've also got the alternating thing going on, so I could have just alternated. Or I can alternate now. Or I've already found V of 4, so whatever. V is positive. Positive, negative, positive. I haven't really answered the question yet, so make sure you answer the question clearly. Like it's there, but I haven't said it outright. So let's say moving right when V is greater than 0. Okay, where does this thing start moving though, I guess? I need to be careful here. When does this experiment start? At 0, so I'm going to go 0 to 1. And I think at 1 it's not moving anywhere, so I think I'm going to hold off on a bracket there. I just want to say 0 to 1, and then 3 to infinity. Then moving left, when V is less than 0, from 1 to 3. Right, at 1 and at 3 it's at rest, it's not moving anywhere. So I don't want to include those. I don't want brackets on the moving statement here. Okay. F is always, it seems to me, the hardest part of the question that students struggle with the most. Draw a diagram to represent the motion of the particle. Okay, so I need to know where it starts. So always start with S of 0. S of 0 is 0. I like to think of it as a number line here. So S of 0 starts there when t is 0, and my number line is an S number line. So I'm trying to visualize what the particle is doing. So at t equals 0, I'm starting at 0. What should my next, just phrase it correctly here, what would be a critical point to consider? What time might I want to plug in next? 1. I'll do 1 and 3. So S of 1. Again, I got to go all the way back to the S statement here. So 1 minus 6 plus 9 is 4. So I'm going to go over to 4. So at t equals 1, S is 4. And I'm even going to put a little arrow on there. But that matches what we said. From 0 to 1, velocity is positive. You move to the right. From 1 to 3, we're moving to the left. So I know I'm turning around and headed back this way. But I don't know how far back until I plug in 3 for S. So 27, or 3 for T into S. 6 times 9 plus 9 times 3. 27 minus 54 plus 27. 54 54 minus 54 is 0. So we came back. Whoops, t equals 3. Okay, we're trying to visualize and sketch out what the particle is doing. It moved to the right, then it moved to the left. And I don't know that I need any more particulars because it's positive from here on out, which means it's moving to the right. So I can just send this thing out forever that way. So now I've got a picture of the motion of the particle. It moved to the right for 1 second and landed at 4 and went back to 0 and then headed off to the right again after that. I guess if we try to put it in words, we'll use t equals 0, so like know when it starts, and then the times when v equals 0, because that's where it could be turning around. So use t equals 0 and the times when v equals 0. It doesn't always start at 0. This makes it a little easier, but it makes it confusing later because when you hit one where it doesn't start at 0, you can't assume it starts at 0. You got to plug in 0 to see where it starts. All right. G and H, kind of look at them together. Find the displacement during the first 5 seconds versus total distance during the first 5 seconds. Okay, displacement is just where I landed minus where I started. So it doesn't matter how you got there. Right? This is back to the track thing. If you see somebody standing at the finish line, you don't know how many, you know their displacement is 0, but you don't know how far they ran. Displacement, S of 5 minus S of 0, so I don't think I found S of 5 yet.
How do we know it's S of 5?
Because it said first 5 seconds. S of 5 is 5 cubed minus 6 times 25 plus 9 times 5. You know what? That's a safe stop, right? So 5 cubed minus 6 times 25 plus 9 times 5 minus S of 0 we already have. S is 0. So I'll leave that as my answer. Total distance, this is where it gets a little bit trickier. I'm going to have to, this is where the diagram helps a lot. S of 5, I kind of want that on my picture so I know where that is. So I'm going to go ahead and get an answer here, because I think I'll need it for total distance. 125 minus 150 plus 45. So that would be 170 minus 150 is 20. So graph not to scale, somewhere out here at 20, t equals 5. Now to get the total distance, I should be able to just like add up the pieces. Like there's a mathy formula for it, but I feel like it's just easier to add them up. So my first piece is 4 meters. My second piece is also 4 meters. And my last piece is from 0 to 20. 20 meters. So 28 meters. The best way to get total distance is from the diagram. There's other ways to do it, but they're more complicated. If you draw the picture, and we'll almost always ask you for the picture, then it's pretty easy to see 4 and 4 and 20, or whatever the pieces are. So just be careful, make sure you add up the pieces. I think that's the easiest conceptual way to understand it, rather than trying to give a formula for it. J, when is the particle speeding up? When is it slowing down? So speeding up is when A and V have the same sign. Slowing down is when A and V have opposite signs. Okay, so signs, that makes me think sign chart. I already have a velocity sign chart, but to see where they're the same and different, I'd really like to have overlapping charts. I think that's going to make it much easier. So I already have the velocity sign chart. 1 and 3, positive, negative, positive. So I already did that. That's from part E. Now, I want to do the same thing with acceleration. Acceleration was 6t minus 12. So I'm going to do the same thing. Let's finish this and then I'll say that. Set that equal to 0. So 6t equals 12. So t equals 2. Something is going on. And so I need to check something less than 2. What would my acceleration be if I'm less than 2? Be negative, and greater than 2 would be positive. Okay, so some people can answer the question already. I like to go overboard and put my pluses and minuses. So all of this is plus acceleration, all of this is minus acceleration. Change it to. So now I've got overlapping velocity and acceleration things. So what's going on from 0 to 1? Are we speeding up or slowing down? Slowing down. And what about from 1 to 2? It'll be this right here. We're speeding up because both signs are negative. And then 2 to 3, they're fighting each other again. So we're slowing down. And then from 3 on, out to forever, they're just speeding up, up, up. Speeding up and slowing down. You put the sign charts together to figure that out. Okay, I hope you've caught that there's overlap with what we were just doing. Velocity is the first derivative. We make a sign chart, increasing, decreasing. Acceleration is the second derivative. So if we're talking about graphs, the second derivative is concavity. If we're talking about motion, the second derivative is acceleration. But it's kind of the same stuff. Take a first derivative, set it equal to 0. Take a second derivative, set it equal to 0. And then answer all the questions about it. All right, today's assignment is worksheet 2. And we'll answer some of those on Thursday.